Recently, one of my friends got infected with corona. The doctor suggested him for home isolation and prescribed some medication. Also, they have suggested him to monitor blood oxygen levels and call them if the blood oxygen levels are less than 95% so that they can take him to the hospital and provide him oxygen ventilation. He is following our channel and he liked one of our previous projects, IoT based COVID patient blood oxygen monitor. He asked me to develop the same thing for him. Also, he has suggested few changes like the oximeter should be owned like traditional oximeter and the data should be shown on the OLED display. I agreed with that because his suggestions make sense. Previously, I made the solution based on the breadboard, which is not portable and he cannot wear it. Also, if he wanted to see the data, he has to log into the Ubidots platform and check the data, which is a longer process. So, I thought the suggestions will make this device more convenient and robust. Recently, I have learned MicroPython, so I decided to develop this project with MicroPython only, so that I will get a chance to use my theoretical learnings and apply them on the practical applications. Finally, the device is ready. We can call it as an intelligent pulse oximeter for COVID patients, which is an upgraded version of the IoT-based COVID patient blood oxygen monitor. This device will monitor heart rate and SpO2 data of the patient and shows them on the OLED display. Also, it will post the same data to the Ubidots platform and then it will trigger an alert to notify the medical staff in case of emergency. Currently, this device is in prototype stage. Hopefully, I will design a PCB and get that PCB manufactured by PCBWay.com. Why? Because we all know that PCBWay.com is an online PCB manufacturing company where we can get our prototypes converted into the real-time projects and delivered to our home. If you wanted to convert your prototype into real-time applications, PCBWay.com is the best option. The link is in the description below. Check out their website. They have a lot of exciting offers. So, without wasting further time, let's see how did I build this intelligent pulse oximeter. Requirements for this device is ESP32 module, MAX30100 sensor, OLED display, Vero board, connecting wires, soldering kit and some cloth hanging clips. Circuit diagram. Here is the circuit diagram to interface MAX30100 and OLED display with ESP32. Since we are using I2C protocol, both modules can be interfaced with ESP32 with the same pins. After connections, the circuit would be something like this. Don't worry, I will guide you step by step to make this arrangement in the next few minutes. If you are not interested to make this kind of arrangement, you can still use the breadboard to connect the device as shown here. Let's see how to make this device. The idea is to replicate the conventional pulse oximeter and add intelligence to give an alert to the medical staff whenever the critical situation occurs. So, intelligence is purely based on the coding part, which is related to the Internet of Things. That part will be discussed later in this episode. First, let us complete the replication of the pulse oximeter. We are going to achieve this by soldering MAX30100 inside of these two Vero boards and OLED display on the top. Similarly, ESP32 will be soldered on the bottom of the pulse oximeter. First, solder MAX30100 on the one side of the Vero board. After that, solder two pull-up resistors. If you want to know why do we need to solder these two pull-up resistors, follow the above I button. After soldering of pull-up resistors, place the ESP32 on the other side of the Vero board. Now connect the I2C data pins SCL, SDA and power pins VCC and ground of the MAX30100 with ESP32 respective pins. Take another Vero board and solder OLED display as shown here. Now connect the I2C data pins SCL, SDA and power pins VCC and ground of the OLED display with ESP32. Make sure you are using flexible wires for this connection. Otherwise, the wires will break. After connections are done, take two cloth hanging clips and place them between the two Vero boards as shown here. Then stick both of them with super glue. Make sure the super glue shouldn't touch any connection. If so, short circuit will happen. So take care of it. Finally, the pulse oximeter device is ready. Now it's time to program the device. Connect the ESP32 with laptop. Open ESP IDF PowerShell and erase the previous firmware. Then install the latest MicroPython firmware on the ESP32 module as shown here. Install the Visual Studio Code on the computer along with PyMaker extension. If you don't know how to do it, refer to the above I button link. Now open the Python project. Make sure PyMaker is enabled. Then upload the program to the ESP32 as shown here. After successful uploading, the program will automatically run and you can see the SpO2 and heart rate data on the both PyMaker terminal and OLED display. So, we have successfully achieved 2 suggested changes. Up to this part, every pulse oximeter can do. But here comes the intelligent part of the oximeter. This oximeter not only display data on the OLED display, it will also post data to the UB.IoT platform using MQTT protocol. Heart rate and SpO2 data can be seen like this. I have also added a feature to post the location of the device. It's always a good feature to have the location information of the patient so that medical assistants can reach to the location early in case of emergency. We can also make this device more intelligent by adding an event to trigger an alert whenever the critical situation occurs. This alert includes voice calls, messages, emails, and Telegram messages. This alert can be configured as per the user's request. Users can configure to send alerts to their family members, caretakers, or family doctors. It's up to them. I have already explained how to configure it in the previous episode. You can follow the above I button. Isn't it intelligence? Yes, it is. That's why I call it as an intelligent pulse oximeter. This can be a life-changing moment for a COVID patient who is suffering from low blood oxygen levels. This project helped my friend to battle with corona. Now he is fully recovered from the corona and he is healthy now. Stay home and stay safe. Also, stay tuned to Electronics Innovation for more interesting projects. See you on the next interesting episode. Bye bye.